All right, time for the second half of our 1.1 lesson, solving simple equations. We talked previously about adding and subtracting. Now let's talk about multiplying and dividing. So before we were zeroing out a constant. Now we want to one out a coefficient. All right, one out a coefficient. Remember, the coefficients are the numbers that are with a variable. So in this case, our first example, we have negative 7y. That negative 7 is our coefficient. And when we one out, we are still left with, in this case, a y. So some examples here would be 2 divided by 2. That's going to equal to 1, right? Or negative 1/2 times negative 2, that equals a positive 1. Or even n divided by n, that's going to be a positive 1 as well. So let's get some practice with this. We have negative 7y. Are we multiplying or are we dividing? Hopefully you said multiplying. So the opposite of multiplying using that inverse operation would be to divide. So I need to divide our left side by negative 7. But whatever I do to one side, I have to do to the other. So I need to divide the other side by negative 7. Negative 7 divided by negative 7 times y. This is going to be the same as 1y. And then we have a negative divided by a negative is going to be a positive. And we have 91 over 7. Well, 91 over 7 is the same as 13. There are 13 sevens in 91. So we know that y equals a positive 13. To do our check, we plug that 13 in where y was. So we'll have negative 7 times 13 is equal to negative 91. So we should have negative 91 is equal to negative 91. Yes, that is true. Remember, we need to have it so that even my 4-year-old can see that that's true. My 4-year-old understands 91 and 91. He's kind of smart. Don't mean to brag, just true. So let's take a look at our next one. We have negative 3 equals negative 1/5 x. We want to get x by itself. Now, fractions can be a little tricky for some of us. If it helps you, then just put that little multiplication sign right there. And think about, well, what's the opposite of multiply? Divide. So I need to divide everything on my left side here by a negative 1/5. All right, we're dividing everything. Whenever we divide something by itself, it's going to one out. So we will be left with 1x. Whatever I do to my right side, I have to do the left. So I need to divide negative 3 by negative 1/5. This is why we reviewed fractions, right? So we need to remember that we need to keep our first one. I'm going to take my negative 3 and turn it into a fraction by putting 1 as our denominator. Change my division bar here to a multiply, and then reciprocate or flip. So I flip my negative 1/5 to a negative 5 over 1. Multiplying fractions, easy. You got this. So we've got negative 3 times negative 5 is a positive 15. And then 1 times 1 is 1. So really, that means we have 15 is equal to x. When I go to check this, I'm going to plug in 15 for my x here. Kind of a wonky looking x, but that's okay. It's still x. And now we've got negative 1/5 times 15. So I have negative 3 equals negative 1/5 times, I'm going to change my 15 into a fraction, so 15 over 1, and then I multiply straight across. So that would be negative 3 is equal to negative 1 times 15 is 15. And then 5 times 1 is 5. So that means I have negative 3. Well, negative 15 over 5, I can reduce that down and simplify it down to negative 3. Even my 4-year-old can understand 3 is the same as 3. Let's do 2 more examples together because this can be kind of weird. So our next example, there we go. Our next example is this one right here. So we have negative n divided by 5 equals negative 3. For this one, I'm actually going to change this a little bit, just rewrite it so that I have n over negative 5. All right, that negative can go with the numerator or it can go with the denominator. I'm just going to stick it with my constant, that 5, so I can get rid of it easier. So I have n over negative 5 equals negative 3. We have division here, The opposite of divide is to multiply. So I need to multiply by -5. Multiply both sides by -5. -5 divided by -5, this 1's out, so I'm left with 1n. And then we have -3 times -5. Negative times negative is a positive. 3 times 5 is 15. So that means I should have n equals 15. I need to check my answer, so I'm going to plug 15 in for n. And we have -15 divided by 5. 15 divided by 5 is 3. It's a negative. -3 does equal -3. The last one I wanted to look at like this is a literal equation. So we have m divided by z equals y, and we want to solve for m. We want m to be by itself. I am dividing by z. So in order to get m by itself, I have to get rid of z. I need to 1 it out. The opposite of divide is multiply. So if I multiply both sides by z, then I end up with z divided by z times m equals y times z. Z divided by z, anything divided by itself is always 1. So I have 1m is equal to y times z. Or I can write that as m equals yz. We know that if we have two variables written next to each other, that really means to multiply. All right. The next two examples are word problems, your favorite. Let's start with a question about the Olympics from 2012. So Usain Bolt won the 200-meter dash with a time of 19.32 seconds. We want to write and solve an equation to find his average speed to the nearest hundredth of a meter per second. Some of you remember from science that we have distance is equal to rate times time. So speed is the same thing as our rate here. So we know it was 200 meters. We are looking for his rate. We don't know it. And the time was 19.32 seconds. I want to get R by itself, right? I want to find the rate. So I have a times going on here. The opposite of times is divide. So I need to divide by 19.32 seconds. So I'm going to divide this side by 19.32. So I'm left with R on the right, and on the left, I have 200 divided by 19.32. That means I have R is equal to 10.35 meters per second. So when I go to write my final answer, because I need this in the form of a sentence, Bolt's average speed is 10.35 meters per second. Well, let's say we wanted to find something else. Let's say we wanted to find how long it would take him to run a 400-meter race. In the same amount of time that he ran the 200, what if Usain Bolt ran 400 meters? So we actually know our rate this time. We just found it right here. So in this case, for my rate, I'm going to plug in 10.35. We don't know the times we're looking for. I try to write cursive T's for time. That way you can tell it's not the same thing as a plus. And then distance. This time, we want to know how fast he'd run a 400-meter race. So I want to have my time by itself. It's being multiplied by 10.35. That means I need to divide both sides by 10.35. So now we have a time is equal to 400 divided by 10.35 is 38.65. So if Bolt completed the 400 meters, it would take him 38.65 seconds. I know there's a lot that goes into running races, but this is, just how the word problem worked out today. So go ahead and try the skills practice that is posted on Big Ideas. Some of you would call it homework. I call it skills practice. And let me know if you have any questions.